Hi everyone, this is Dr. Nak. Today we're going to talk about linear inequalities. Now, do not panic because you see A's and B's and C's and you don't see any numerical values, but we're in pre-calculus now, so let's do it. So number one, it says if A is less than B and if C is greater than 0, then AC is less than B times C. So basically this is telling you that if some number A is less than some number B, and if C is positive, then when you multiply them together, A times C and a B times C, your inequality sign does not change. All right, and number two, it says if A is less than B, and if C is less than 0, that means that C is negative, then A times C is going to be greater than B times C. All right, and then property 3, it says if A is greater than B, and if C is positive, then A times C will remain greater than B times C. And the last one is this, if A is greater than B, and if C is less than 0, that means C is negative, then A times C is going to be less than B times C. All right, so this is my translation of those properties. Basically, it's telling you that when you multiply or divide by a negative quantity, the inequality sign switches. Now, let's keep going with more properties. Property number 5, it says if A is positive, if and only if 1 over A is positive. So this double arrow in a math class, we call it if and only if, which means that if A is greater than 0, then 1 over A is greater than 0. Or you can start out from 1 over A is greater than 0, then A must be greater than 0. Now, the last one, it says if A is negative, if and only if 1 over A is negative. So here are my words. Basically, it's telling you that the reciprocal of a positive number is positive, and the reciprocal of a negative number is going to be negative. Let's keep those properties in mind and let's start doing some examples. Example number 1. Check whether the indicated value of the variable satisfies the given inequality. All right, so let's go with part A. So suppose that the value of x is negative 2, and inequality is given by 3x plus 4 is, remember, this is strictly greater than negative 2. So what the question's asking you is this: if I replace our x with negative 2, is the left-hand side is going to be strictly greater than the right-hand side? Well, let's check. Okay, so I'm going to write it as check. All right, so when x is negative 2, then our inequality becomes 3 times negative 2 plus 4. Now the question is this going to be strictly greater than negative 2? So this is what the question's asking. All right, so let's compute the left-hand side. It says 3 times negative 2, so what's that? Negative 6 plus 4, which is same thing as negative 2. Now the question is this: is negative 2 strictly greater than negative 2? What do you think? Answer is no. Negative 2 equals to negative 2. But we have a strict inequalities going on. So what we're going to say is that the value x equals negative 2 does not satisfy the inequality. Because after I plugged in the value, our inequality is not true. So here's my answer. X equals negative 2 does not satisfy the inequality. Now, let's go with part B. We're going to play the same game. Now, our value is x equals negative 5 over 4, and our inequality is given by 4x is strictly greater than negative 4. So we're going to do the same thing. We're going to check by plugging in x equals negative 5 over 4 in place of x. So what do we get? We're going to have 4 times negative 5 over 4. Now the question is this going to be strictly greater than negative 4? All right, so let's keep going then. So if I multiply these two together, then remember 4 is same thing as 4 but 1, right? So 4 goes into 4 ones. I could cancel those out. So what do we got? -5. Now the question is this going to be strictly greater than -4? So what do you think? Well, let's just draw the number line, right? Oh, pretend that's a number line. Suppose this is 0, then -4 comes first, and then -5 comes next. Now remember, on the number line, left you are, smaller you are. So with that said, -5 is going to be less than -4. So is this inequality true? I don't think so, because this is telling us that -5, is it greater than -4? So again, answer is no. So this means that x equals -5/4 does not satisfy the inequality. All right, let's take a look at example 2. It says solve, express your answer in interval notation. All right, so let's first go with part A. We have 3x minus 7 is greater than 2. Now, what you need to do is this. Pretend this is an equal sign, let's just say, right? How would you solve for x if you have to? Well, I would add 7 to both sides, right? And then at the end, since I want to solve for x, I would divide it by 3 on both sides. So we're going to do the same thing. However, remember, when it comes to inequality, if you multiply or divide it by the negative quantity, on your next step, you have to switch your inequality sign. All right, so keep that in mind. But okay, here we go. So here I'm going to add 7. Then we're going to have 3x is greater than 9. Now, in order for us to solve for x, we just divide it by positive 3, right? So that means that your inequality sign stays the same. So what do we got? We have x is greater than 3. Now, since we're going to have to express our answer in interval notation, so let's just pretend this is 3. So x is greater than 3. So that means that you're going to have an open circle or open parentheses, and then you're going to be shading towards the right hand side. So just translate that. What do we get? Open 3 to positive infinity open. So that's going to be our answer. Okay, now let's look at part B. -2 times the quantity x plus 3 is less than 8. All right, so step number 1, what would you do? I would distribute the -2 to each side. Okay, so let's do it. So if I distribute, let me just make this notation here. So what do we get? You're going to have -2x, and then -2 times 3 is -6. It's going to be less than 8. All right, now what? Add 6 to both sides, and what do we get? We're going to get -2x is less than 14. All right, now how do you solve for x? Yes, you're going to have to divide it by -2. Divided by -2, right? So what are we going to do? Yes, switch your inequality sign on the next step. All right, so dividing by -2, then boom, you're going to have to switch that inequality sign. I don't know why I wrote that inequality sign really big, but oh well. So here you're going to have x is greater than -7. All right, to express our answer, so let me just write this as -7. So x is greater than. So you can have an open circle if you want, and then shade this side. Or you can have open parentheses like what we did in part A, same thing. So here our answer is going to be open -7 to positive infinity. And there you go. All right, now let's look at part C. It says 4 minus 3 times the quantity 1 minus x is less than or equal to 3. So again, order of operation matters. So first step, what I'm going to do is I'm going to distribute the 3 to each term in the parentheses. Then here, what do we get? We're going to have 4 minus 3. Now you have a -3 times the negative x, right? You can think of it in that way. So the sign changes to plus 3x. And then I'm just going to drop down our less than or equal to, and then 3. All right, so now what can we do? Yes, we can combine 4 minus 3. That's 1. So we're going to have 1 plus 3x is less than or equal to 3. Now what? Subtract 1 from both sides, then we're going to have 3x is less than or equal to 2. All right, now we're going to have to divide this by 3, positive 3. So your inequality sign stays the same. So here what we're going to get is x is less than or equal to 2/3. So let's express our answer. So I'm just going to go over here. All right, so this is going to be 2/3. Now we have a x is less than or equal to. So in this case, you're going to have a closed dot, or it's same thing as the closed bracket. So x is less than or equal to, so we're going to be shading this side. All right, so translate that. Remember, this is negative infinity side, this is positive infinity. So our answer is going to be negative infinity to 2/3. Now this one is closed. All right, so here's our answer. Now, this is what I see often, so let's not do this. Okay, this is what not to do. This is the illegal math that I'm about to tell you. Okay, so remember, order of operations matter. So you're going to have to multiply first. Multiply is same thing as distributing. That's same thing. Now, what I see most of the time is, I know it's so tempting. You so want to go 4 minus 3 and make that into a 1. And then you have 1 minus x. But please don't do that, okay? You do not subtract first. Remember, you have to multiply first. But anyways, I just wanted to point that out. Now let's try part D. What do we got? We're increasing the level of difficulty little by little, as you can tell, but we got this already. We got 8 minus 4 times the quantity. 2 minus x is less than or equal to negative 2x. All right, so again, do not do 8 minus 4 first, okay? We're going to have to multiply first, which means that we're going to have to distribute the negative 4 to each term in the parentheses. All right, so let's do that. I'm just going to make this sign like this. Okay, so what do we got? We have 8 minus 8, and then you're going to have plus 4x is less than or equal to negative 2x. All right, so now we're going to go 8 minus 8, that's 0. So what we're left with is just the 4x is less than or equal to negative 2x. Now, what is the biggest difference between this problem and the previous problems that we did? Well, what I see is this. Before, right, you're only given one x only appearing on one side of the inequality, but here, your x appears on both sides. But regardless, remember, if you're going to solve for x, you have to bring whoever that has an x attached on them on one side of the equation, if that was an equal sign. So same idea holds, all right? So what we need to do is, let's just move this one. We're going to move negative 2x onto the left-hand side by adding negative 2x to both sides. All right, so then what do we get? I'm going to have plus 2x and then just plus 2x. Now what? We can combine the like term. 4x plus 2x is 6x. Is going to be less than or equal to, now, negative 2x plus 2x. Now, they're going to cancel each other out, so that's going to give us a 0. All right, so now let's divide it by 6. Remember, we're still trying to solve for x. Dividing by 6, then we're going to have x is less than or equal to 0 over 6. Now, 0 over 6 is same thing as 0. All right, so I think we got this. So let me just denote this by 0. X is less than or equal to, so you can have a closed dot because of the equal sign, close bracket, and then we're going to be shading the left-hand side. All right, so our interval notation is going to be negative infinity to 0, close bracket. All right, so here it is. Let's try E. It says negative 5 is less than or equal to 4 minus 3x, which is less than or equal to 2. So now what is the biggest difference between example E and all the previous one? I think you see it. Do you see that we have two inequalities going on? But do not panic, okay? Remember what you're doing. You're trying to solve for x. So what you want to do is you want to isolate the x. All right, so how am I going to do that? Well, this positive 4 is in the way, right? So we need to get rid of it. So how do I get rid of it? Is by subtracting 4, right? But if you're going to subtract 4 to this term, that means what? You better be fair and subtract 4 from the left-hand side and then also to the right-hand side. So that's exactly what we're going to do. So we're going to have negative 4. Well, I better be fair and take negative 4 from all of it, all of the sides. Then here what we're going to get is negative 9 is less than or equal to negative 3x, and then which is less than or equal to 2 minus 4 is negative 2. Now what? Again, we're trying to solve for x, right? So that means what? Negative 3 is in the way. So how in the heck am I going to get rid of it? You're right. You're going to have to divide this by negative 3 to solve for x, right? So now if you're going to divide it by negative 3 in the middle term, you better be fair and do the same thing on the outer parts. Okay, so that's exactly what we're going to do. So we're going to be dividing by negative 3. Negative, dividing by negative. All right, so what's going to happen? Yes, your inequality sign better switch. I'm just going to write it in red. All right, so what do we get? You have a negative 9 divided by negative 3. That will give us a positive 3. Now here you're going to have x, and negative 2 plus negative, divided by negative 3. That's going to give us positive 2/3. Now, to check your answer to make sure that it's right, just read it through. So x, so you can think of it like this. X is sandwiched between 2/3 and 3. So first of all, is 3 bigger than 2/3? I think that's okay, right? So this inequality does make sense. Now, how in the heck are we going to write that as an answer, right? So again, bust out your number line. So where is 2/3? So 2/3 is smaller than 3. So you got, let's just pretend this is 2/3 and this is 3. So notice that, okay, let me just read this part. So this is telling us that x is greater or equal to negative 3. And at the same time, x is going to be less than or equal to 3. So where are we going to be shading? You're right. In between negative 2/3 and 3. So here, I'm just going to make a closed dot, or you can just put, again, bracket like this. So if I have to do this step by step, right? So x is greater or equal to 2/3, so I'm going to be shading this side. But at the same time, x must be less than or equal to 3. So again, what we're going to get is shaded region between 2/3 and 3. So how do we express that in interval notation? It's just close 2/3, comma 3. And there you have it. How are you doing? Are you kind of getting hang of it? I hope so. But anyways, let's look at part F. Okay, do not panic because you see fractions. All right, fractions are cool. All right, so now let's take a look. Part F, it says negative 3 is less than or equal to 2x minus 1 all over 4, which is strictly less than 0. And remember what we're doing. We want to solve for x. All right, so let's take this one step at a time. Okay, so first of all, what I want to do is this. I want to get rid of this fraction, which means that I want to kill the 4 on the bottom. So what do we need to do? What we need to do is, do you see that if I multiply by 4 on the numerator, then do you see that this 4 and that 4 is going to cancel each other out? So that's exactly what we're going to do. All right, so the trick is this: multiply every term by positive 4. So here I'm going to have, I'm running out of room, so I'm going to multiply this guy by 4, this guy by 4, and then 0 by 4. All right, so ready? So what do we got? We have 4 times negative 3, so we're going to have a negative 12. Now less than or equal to, so now notice that this 4 and 4 is going to cancel each other out. So what we're just left with is just 2x minus 1, and then this is going to be less than. Now what's 0 times 4? That's just 0. Look, no more fractions, right? So now we're going to solve this inequality just like what we did in the previous example. So here what I would do is just add 1 to both sides. Then what do we get? we're going to have negative 12 plus 1 will be negative 11 is less than or equal to 2x, and this is strictly less than 0 plus 1 is just 1. All right, now we're almost home. Now what? Divided by 2, okay? Because we want to solve for x. So if I'm going to divide a middle number by 2, I better be fair and divide everybody by 2. So what do we get? We have a negative 11 over 2 is less than or equal to x, which is less than 1/2. Now, does this make sense? You have to think about it before you bust out your final answer. Is negative 11 over 2, is it less than positive 1/2? Yes, it is. So this inequality does make sense. All right, so let's just write that out. Let me just go like this, number line. Suppose this is negative 11 over 2, and this is 1/2. Okay, so this is telling us that x is sandwiched between negative 11 over 2 and 1/2. If you don't see that right away, it's okay. Just take one step at a time. So cover the left-hand side, right? Then just read what we got here. So this is telling us that x is strictly less than 1/2. So what does it mean? I'm going to have an open parentheses or open bracket, I should say, and then x is less than that. So I'm going to be shading this side, right? Now, but at the same time, this is telling us that, well, x is going to be greater or equal to negative 11 over 2. So that means what? Greater or equal to, so I'm going to have a closed dot or closed bracket, and I'm going to be shading this region here. All right, so just translate that directly below to express your answer in terms of an interval notation. So what do we got? We got a closed negative 11 over 2, comma, 1/2, and then this side is going to be open. All right, and so that's going to be our final answer. Okay, please don't hate, okay? So here's next, let's just do 2 more examples, all right? Remember, more practice we get, we're gonna get better at it, all right? So think of it in that way. So let's go with part G. So what do we got? We got 0 is less than 1 minus 1/3 x, and then minus 1, all right? So do you wanna try this on your own and see if you can do it or not? If so, please pause the video and just try it. Why am I pausing? Okay, so I'm going to pretend that you tried it. Okay, so what did you all do first? Well, if I want to solve for x, then I would move this 1. I want to get rid of this 1 by subtracting 1. So that's the route that I'm going to. So I'm going to subtract minus 1. That means I better be fair and minus 1 to everyone. So then on the left-hand side, I'm going to have a negative 1 and less than negative 1/3 x. And then strictly less than 1 minus 1 is going to be 0. And then what should we do? Well, I want to solve for x. So the trick is this. If you want to isolate the x, right, multiply by the reciprocal of negative 1/3. What's the reciprocal of negative 1/3? Isn't that just negative 3 over 1, which is just same thing as negative 3? So that's the trick. Okay, so what I'm going to do here is I'm going to multiply this guy by negative 3. I'm running out of room. That means what? I better be fair and multiply everybody by negative 3. So, because look what's going to happen here. If I multiply by negative 3, remember negative 3 is same thing as negative 3 over 1, right? So first of all, I have a negative times a negative, which becomes a positive. Then you're going to have 3 times 1 divided by 3, which is same thing as 3 over 3. So which just gives us 1 and then x. That's exactly what we want. All right, so let's do it. We have a negative 3 times negative 1, so which is just going to give us 3. Now, be careful. What do we just do here? Do we not multiply by negative 3? So what's going to happen? You're going to have to switch your inequality sign. So here you're going to have boom, and then boom, just like that. All right, but anyway, so let's just keep going. So then the middle term is going to be just 1x, which is just x. And the right hand side is going to be 0 times negative 3, which is going to become 0. Before you bust out the answer, think about it. Does this expression make sense? I think it's okay, because look, this is telling us that x is less than 3, but greater than 0, right? So it does make sense. So basically this is telling us that x is sandwiched between 0 and a 3. And of course, 3 is bigger than 0, so this makes sense. All right, so let me just bust out the number line. Here is my 0, here's my 3. Okay, so if you want to do it step by step, that's fine. So this is telling us that x is strictly greater than 0. So that means what? You're going to have an open circle or open parentheses. And then the second half, this portion here is telling us that x is less than 3. X is strictly less than 3. So in this case, you're going to have an open circle around 3 or open parentheses, fine. And x is between those two numbers. All right, so let's just translate that. So what do we got? We have an open 0, comma, 3, and then open. And that is going to be our answer. Okay, one last example, all right? So you know what? I think you got this. So what I want you to do is please pause the video and just try it. All right, so let's see what you got. So step number 1, what did you do? Well, if I were you, I want to get rid of the bottom 3, right? So how am I going to do that? Well, multiply by 3 on the top, right? Then I can cancel out that 3 with this 3. So that way I can get rid of the fraction. So that's exactly what we're going to do. The trick is to multiply every single term by 3. So what do we got? We're going to multiply here by 3. And then we're going to multiply here by 3. Multiply this guy by 3. 3, same thing as 3 over 1. So what do we get? We're going to have 3 over 2. And then we multiply by the positive 3, right? So in this case, your inequality sign stays the same. So this is going to be less than or equal to. Now notice that this 3 and this 3 is going to cancel each other out. So we got x plus 1. And then this is going to be less than. So again, remember 3, same thing as 3 over 1. So we got 3 times 3, which is 9, and then over 4. So far, so good. Now what? Subtract by 1. So I'm going to go minus 1, minus 1, minus 1. Okay, so on the left-hand side, what do we have? We have 3 half minus 1, right? So we have a 3 half minus 1 is going to be less than or equal to x, which is less than 9 over 4, and then minus 1. You don't have to write this step out, but I don't want to skip any steps. That's the only reason why I'm writing this. So what we need to do next is this. We need to combine this, right? So that means I need a common denominator. Now what's the common denominator? Well, that will be 2, right? So this left-hand side is going to be 3 halves minus, now I can rewrite 1 in terms of 2 over 2. So this portion is going to become just 1 half. All right, and now I'm going to drop down this less than or equal to, and then x. Now I'm going to drop this strict inequality, so less than. Now let's combine these together. So we have 9 over 4 minus, now the common denominator is 4. So I can write 1 as 4 over 4. Now, which is going to give us 5 over 4, is that right? So what do we got? We got x is, let me just go like this, x is greater or equal to 1 half, and x is strictly less than 5/4. And this answer does make sense because 1 half is 0.2, and then 5 over 4 is 1.25, so it does make sense. So let me just draw the number line. So here is our 1 half. and then 5/4. Now be careful with the closed dot and open dots, okay? So x is greater or equal to 1/2, so we're going to have a closed dot or the closed bracket. And then at the same time, x must be strictly less than 5/4. So you're going to have an open circle or open parentheses, and you're going to be shading this region here. So our answer is going to be closed bracket 1/2, comma, 5/4, and then this side will be open. So there you go. How did you do? Do not get bummed out if you didn't get it right. Just go over it again. Just try it again. You can do it. Example 3. Now let's do some application involving inequalities. So it says that to operate a coffee booth in a shopping mall, it costs $600, that's the fixed cost, plus $5 per each pound of coffee bought at wholesale price. The coffee is then sold to customers for $11 per pound. So let's just read through part A. Find an expression for the operating cost of selling Q pounds of coffee. And part B, find an expression for the revenue earned by selling Q pounds of coffee. And part C, find the break-even point. And part D, how many pounds of coffee must be sold for the revenue to be greater than the total cost. Okay, so let's take one thing at a time. So let's start with part A. It says, find an expression for the operating cost of selling Q pounds of coffee. All right, so let's think about this. Now, it's going to cost, so you already have a fixed cost of $600. And in addition to that, you're going to have $5 per each pound of coffee. So let me denote, so I'm just going to go like this. So let C stands for the cost of selling Q pounds of coffee. All right, so how would you write that? So the total cost is going to be, well, we already have a fixed cost of $600, and after that, it's going to cost us $5 per each pound of coffee. But we're talking about selling Q pounds of coffee, right? So here, our equation of the total cost is going to be $600 plus $5 for Q pounds of coffee. So it's going to be 5Q. So let me box that. So this is going to be the total cost function. And let's take a look at part B. It says find an expression for the revenue earned by selling Q pounds of coffee. Now, since coffee is going to be sold for $11 per pound, right, to the public, the revenue, let me just call it the revenue to be R. Okay, so should I write, do you want me to write everything out? All right, so I'm going to say this. So since the coffee is sold for $11 per pound, the revenue is, let me just call it a R, equals $11 times, how many pounds are we talking about? Q pounds, right? So it's going to be 11 times Q. So revenue means that how much can you make by selling Q pounds of coffee to the public? So that will be 11 times Q, if that makes sense. So let me just box that. All right, now let's take a look at part C. Find the break-even point. So what the heck does that mean? Break-even means the total cost equals to the revenue, right? Again, let me just write everything out. So break-even means that the total cost equals to the revenue. So what do we got? What do we got for cost? Well, we came up with the cost function to be 600 plus 5Q. Now, that whole thing is going to equal to our revenue, which is going to be 11Q. Now, solving for Q, let me see. Let me subtract 5Q from both sides. Then we're going to have 600 equals 6Q. Now, that's a Q, by the way, sorry. And then dividing by 6, what are we going to get? We're going to get, you know what, I'm running out of room, so let me just go on this side. So Q equals 100. Well, what the heck does that mean? It means that in order for us to break even, we must sell 100 pounds of coffee. And that's what you just discovered. Now, if we know that, then part D, we should be able to answer this without writing out any inequalities, but let's just read it through. It says, how many pounds of coffee must be sold for the revenue to be greater than the total cost? Well, since break-even point is 100 pounds, that means what? More than 100 pounds of coffee must be sold for the revenue to be greater than the cost. But let's just figure that out mathematically. So here, what we're going to get is the revenue has to be greater than cost, right? Now, what was our revenue function? Our revenue was 11Q. So this is going to be greater than, what was the total cost? It was 600 plus 5Q, right? So again, we're going to do the same thing, subtract 5Q from both sides. Then what we're going to get is 6Q is greater than 600. And dividing by 6, then we're going to have Q is greater than 100, as we expected. So let's write our answer in sentence. Let me see, how can I phrase this? So more than 100 pounds of coffee must be sold for the revenue to be greater than the cost, the total cost. And I think that's good enough. So let me just box that for our final answer. Oh my gosh, I'm looking at my handwriting right now. Can you even read my handwriting? Oh my goodness, I apologize. So what I wrote was, more than 100 pounds of coffee must be sold for the revenue to be greater than the total cost. All right, let's do example 4. It says, in our pre-calc class, you have scores of 87, 75, 93 on the first 3 exams. Assuming that 100 is the maximum number of points on each test, what must be the range of scores to be on the final exam so that the average of 4 tests is greater than or equal to 80? Write your answer in interval notation. So here, our assumption is this. We're going to have to assume that our regular exams and the final exams are all weighted the same. So suppose our regular exams is worth 15% each. That means that we're going to have to assume that the final exam is worth 15% as well. Anyways, so let me start out with this. So I'm going to let X be the score on the final exam. All right, now what do we want? Okay, great. We already have 3 scores, right? Now look at the question. It says, what do you need to get on the final exam so that the average of all the 4 tests is greater than or equal to 80? So average of 4, right? So that means, what do we need to do? We need to add 87, 75, and 93 and add on the X. and we're going to have to divide that by the number of the exams, in this case 4. So let us write that. So what do we got? We got 87 plus 75 plus 93 and then plus x, whole thing divided by 4, and we want that to be greater or equal to 80. Now our job is to solve for x. So here what I would do is this: multiply both sides by the LCD, least common denominator, so in this case it's 4. So I'm going to multiply the left hand side by 4. That means I'm going to multiply the right hand side by 4. So then what's going to happen is that, notice that we can cancel out the 4. So all we have to do is we're going to have to add 87 plus 75 plus 93, so that's 255. And then add on the x. Now that's going to be greater or equal to 320. Is that right? All right, now let's solve for our final exam score. So we're going to have to subtract 255. So then we're going to have x is greater or equal to 65. Wow. All right, so what have we just discovered? In order for you to get an 80%, all you need to do is score greater or equal to 65% on the final. But in our class, let's not do that. Please score greater or equal to 90% on the final. That will be more ideal. But anyways, let me just write down our answer in sentence. So I'm just going to write it as, in order to get greater or equal to 80, you must get 65 or above on the final exam. All right, so now please note this. For our class, our regular exam and a final exam is weighted a little bit differently. Our final is weighted just tiny bit more than a regular exam. But anyways, if you want to see that calculation, I'll be more than happy to show it to you. Now I'm going to stop here, so great job everyone, and if you have any questions at all, please let me know. Good job!